Hi everybody, in this video we're going to talk about a different property of stars, the composition of stars. And I'll make this a really short video. If you want it to be, the too long didn't watch is the composition of the stars is pretty much the same as the composition of the sun because most stars are overwhelmingly similar, then they are different, and the sun is a star. Okay, hopefully you will actually watch. It's not going to be that long of a video. But let's just go ahead and talk about the composition of the stars. This didn't really fit in anywhere else, so it is only a few slides long. But let's go ahead and look at the composition. Well, before I actually get to that information, how do we determine the composition? Exactly as we've talked about in the past. No new ways. You take a spectrum of a star. You look at what absorption lines are there, what emission or what absorption lines exist in the spectrum, and if you see it, then it's in the star. So we can get the composition by spectroscopy. All right, so before we actually talk about the composition of the stars, let me tell you about another weird thing that astronomers do. This list is starting to get a little bit long, isn't it? But this one hopefully makes it a lot easier because the periodic table here is long. There's 118 elements. I think we're up to 119 now, or did we get rid of 118 and we're down to one? I think that's what we did. We're down to 117 elements on the periodic table now. Maybe it's 119. Don't quote me on that. There's a lot. That's the point. And you might be thinking like, oh my gosh, if I want to know the composition of the stars, pretty much most of these elements, not these crazy ones that are only created by humans, are there in stars. But primarily, stars are going to be made out of hydrogen and helium. And if you remember the composition of the sun, it's 0.1% by number of atoms, everything else. So no, you're not going to have to know how much. Well, it is important to know things like how much carbon, nitrogen, and oxygen, and we do study those things. But in general, when we're talking about uh, things that stars are made out of, and we're talking about the composition of stars, we have hydrogen, helium, and then everything else, everything that is a more massive atom than hydrogen or helium. And we call all of those everything else element number 3 and greater metals. So here's the periodic table of elements. Here's the astronomer's version of the periodic table of elements. We have hydrogen, helium, and metals. So makes things a little bit easier. Yes, we will have to talk about the fact that we break down the metals. We have to know how many of each things are each amount of carbon, how much oxygen, how much nitrogen, things like that, how much iron. That does become part of our story. But in general, the term that we're talking about when we say composition of stars is how many metals do they have? How much of everything else? Because it's sort of an afterthought. So whenever we talk about the relative amounts of metals, we're talking about the metallicity of a star. And it ranges from about 10,000 times less metal rich than our sun, our solar composition. So extremely metal poor stars. These are the stars that were formed very, very early on whenever there weren't very many heavy elements around. So they're pretty much made out of only hydrogen and helium. They're extremely metal poor, all the way to about 10 times more enriched with metals, elements heavier than helium. So 10 times more than the solar composition. And that pretty much is the entire range of compositions for stars. So what we have are hydrogen and helium, and by number of atoms, 91.2%. This is the sun. This is the sort of this is what we call solar composition. 91.2% of the atoms in the sun are hydrogen, 8.7 are helium, 0.1% are metals, everything that's more massive than hydrogen and helium. These are the numbers by mass. Oh, and there's a mistake. That should be 1/100,000th. Sorry about that. But that's how we actually do the composition of stars. We have hydrogen and helium, overwhelmingly hydrogen, which is great since that's our fuel source for fusion of hydrogen into helium in the cores of stars. And then we have helium, and we got everything else. And we're going to see later on that this is essentially the composition of the universe itself. Almost entirely hydrogen, if we're talking about the elements of the universe, secondarily helium, and roughly the same breakdown that we see in stars, because the stars are made out of the stuff of the universe, and then just a smattering of all the other elements. How do we actually know all this? Spectroscopy. And the person that actually was able to figure this out, to crack the code to figure out what the actual stars in the universe, what they're made out of, which is the gateway to understanding the composition of the universe itself, was a scientist named Cecilia Payne-Gaposchkin and her 1925 PhD thesis, working with people like Andy Jump Cannon, developed methods of using things like the Bohr model and looking at the specifics of each different spectral line and understanding the specifics, the widths of the lines, the depths of the lines, the strengths of the lines compared to other spectral lines of different elements. Being able to do those sorts of comparisons at a really, really fine spectral analysis level was developed a method to determine the relative abundances of elements based on a spectrum. And through that, was able to look at the spectra of stars and see that they are overwhelmingly hydrogen gas, secondarily helium gas, and everything else is an afterthought. It's a little bit crazy to think about, but prior to this, prior to Cecilia Payne-Gaposchkin's PhD thesis, the running thought was that maybe stars are made out of iron. They're giant hunks of iron in the sky. So this really unlocked, and for the first time, we knew that the stars themselves are made out of hydrogen and helium, which really led us to understand that the universe, if you look at the elements of the universe, it's pretty much all hydrogen and helium. All right, so thank you for tuning in to this really quick video. Hope you now understand the composition of the stars.